thanks everyone for being here in this very last presentation of the day. So I'm Carlo, software engineer at Streamsphere Labs. We are the team behind Polkadot-API. And yeah, I will present today how to build a modern DAPP using Polkadot-API. So quick overview on the presentation. First of all, for those of you who are or might be not familiar with Polkadot-API, what is it? What is Polkadot-API? Then we want to delve into the status quo of decentralized applications. What is actually going on? And then we want to see how the design principles of PAPI are trying to solve many of these issues that we currently find in DAPP development. And then the cherry on top of the cake, I will invite JOSEP to the stage. He will talk a bit. He will do a quick demo, hopefully successful, talking about an important thing that we are solving at PAPI. And we will just wrapping up with what's coming in PAPI development and a quick Q&A session, hopefully, if we have time. So what is PAPI? So first of all, PAPI is a suite of TypeScript libraries. We want them to be composable and modular. And they are meant to interact with Polkadot networks, in particular networks that are built with Frame. We want them to be the building blocks for Polkadot in TypeScript. In particular, our top-level client that simplifies massively, as we will see after this, the development of decentralized applications. And besides that, our CLI is as well called PAPI. Our CLI is very useful in the code gen part that Josep will explain a little bit later. So yeah, let's dive into it. What's happening in the dApps development world? TLDR, Polkadot.js. So yeah, most ongoing dApps currently use Polkadot.js to connect and interact with Polkadot networks, and this presents some issues that I will delve now into them. So in the last years, Polkadot.js entered an almost maintenance-only mode. It hasn't adapted natively, let's say, to changes that happened in our networks. Features like XCM, the newer metadata versions, etc., do not have a first-class support in Polkadot.js. Then as well, Polkadot.js uses the legacy JSON RPC API, which is actually not spec'd. And this complicates, in a big scale, the integration with light clients and as well with other node implementations different than the parity Rust one. So Polkadot.js was born at the same time as Polkadot was growing as well. And it had the same lemma of Kusama, expect chaos. But now that Polkadot reached a more mature state, Polkadot.js hasn't adapted to that. And while growing, ended up having a monolithic design. Even if it's split in several packages, in the end, these packages are tightly coupled, ones with each other, and the boundaries are not well set. For example, an example of leaky abstraction, it is almost impossible to work with scale encoding and decoding directly using Polkadot.js without constructing the whole type def. And now, talking about types, the type registry. This is one of the worst things, in our opinion, in Polkadot.js. Before metadata v14, type registry was actually necessary to construct extrinsics and types in general. But now, with metadata v14, 15, and the coming versions that will end up being released, this is not necessary anymore, because metadata is already self-descriptive. And besides that, even knowing that, Polkadot.js keeps using this type registry, and this makes Polkadot.js being difficult to maintain, improve, etc. And besides that, dApps being developed with Polkadot.js are forced, let's say, to take an after-the-fact approach to runtime upgrades rather than proactive. And we will show in the demo how PAPI solves this issue. In general, all this together leads to a poor performance, both in bundle sizes, close to a megabyte in the index bundle, depending on the use case, and as well to high memory consumption, in the hundreds of megabytes, of course, depending on the usage. Now, what is going on with PAPI? So the first design principle, a thing that is very important to us, is that PAPI is modular. We split our code base in multiple layers with an atomical mindset. So every library does just one thing, but it does it really well. For example, we have scale TS that defines the primitives, encoders, and decoders of scale. Then, on top of that, we have the substrate bindings. We create the most important encoders and decoders in DAPP development. And then on top of that, we have the metadata builders that are dynamically generated to encode and decode extrinsics, events, etc. Our client is as well designed to only use the new JSON RPC API, which is actually spec'd. And it has several improvements compared to the legacy one. First of all, automatic compatibility with light clients, since small dot server implements this JSON RPC API. And as well, it facilitates the creation, implementation, and maintenance of other node implementations, different than the parity RAS one, potentially adding more resilience to the network. Then we take advantage and also heavily rely on runtime metadata. We only support chains that have metadata v14 or ahead, which are actually the vast majority of the active ones. And this has some important benefits. First of all, we don't need a type registry. We don't have a type registry. And every value that the Polkadot API consumer gets or inputs to the library is strongly typed, both in terms of TypeScript during development time. Thanks to our code gen, we generate dynamically TypeScript types for every metadata that the consumer may want to use. And as well, in terms of runtime, we check during the execution of the DAPP if actually the network, the types found in the current network are compatible with the ones that the developer generated in development time. Josep will dive into that. And together with this modularity, we were able, connecting to the previous talk as well, we were able to build Merkleized metadata library, which is a TypeScript library to generate the new, the Merkle, basically the metadata digest that is present in current runtimes. We were able to develop this really fast, thanks to this modularity that I was explaining before. And with these same principles, it helps wallets and other consumers to integrate with signers that need it, such as Ledger. And having all of this as foundations of our library, focusing on performance, it's actually really easy, because our bundle sizes remain small. We lazily import most of the packages that are being used in the top-level client. And as well, the memory consumption is improved compared to other clients, and it's actually top of the notch. And now I want to invite Josep to the stage, so please come, and let's give him a warm welcome. He will present, actually, now we can switch the computers. He will present DAPP that reacts on the fly to a runtime network, so I leave you with him.
Hello there. My name is Josep. I'm team lead of Polkadot-API, if I don't kill myself. So, hi. So what you have here is like a very simple DAPP implemented with PAPI. Super, super simple. Doesn't do anything fancy. We're going to see it in a moment. And yeah, as Carlo explained, when I knew that I had to do a live demo, I was like, OK, where should I put the focus on? Like, should it be small bundle sizes? Should it be small memory consumption? Should it be the really good support that we have for the light client? And then I realized, like, there is something that is a lot more painful when it comes to DAPP development, which is the fact that our DAPPs constantly break because there are random upgrades, right? Like, if you're a DAPP developer, right, like, you have your perfect DAPP, and you know there is this random upgrade around the corner. You actually know what the random upgrade is going to do to your DAPP. What can you do? What can you do to deploy a DAPP that is going to anticipate that random upgrade and that it will keep on running, right? So in this simple demo, I have simplified some code that uses Polkadot-API behind the scenes in a React DAPP. And it's a proof of concept of what it can be done with Polkadot-API. Just for the record, there is another library being built on top of Polkadot-API called Reactive.dot, I believe, from Tien, ex-Talisman, that will make this kind of interactions with Polkadot-API simpler. I'm not using it in this demo, but just keep an eye on it. OK, so again, let me show you this is a super, super simple DAPP that, you know, doesn't do anything fancy. It's just like, oh, no, sorry. Too nervous, sorry. All it does is to send some transactions. So now it's been validated and broadcasted. We should see here an event as soon as there we go. And you can see here that the DAPP is doing what it's supposed to be doing. And now it's in the best block. Eventually, we'll finalize. And when it's finalized, this light box will disappear. OK, cool. Now, imagine that you're a DAPP developer, and that dreadful moment comes in, right? Like you're told, like, hey, by the way, like there is a runtime upgrade coming. It's happening in a week. And like the balances transfer allow death and balances transfer keep alive are going to change a little bit. Nothing big. Now there's a new field that you need to pass in, which is like the concept, right? Like, or a memo. Like in case people want to, like put in there some sort of remark of the reason why the transfer is in. Like, OK, it's an easy change, right? But like, if you build your DAPP with POLKADOT.JS, that maybe I don't know what you're going to do. Maybe you're going to set the alarm at like 3 a.m. in the morning when it gets enacted, and then try to update your DAPP or something like that. I don't know what people do. Like it's not easy. But if you have built your DAPP with POLKADOT-API, well, it's easy. You just come here to your DAPP and you do pm PAPI add, and then you add some new descriptors. You can add descriptors based on a WASM version. You can add descriptors based on you can pass an RPC API. You can pass a change spec. We're going to add very soon the option of passing a referenda. And if that referenda enacts a runtime upgrade, it will pull the WASM from there, and it will get the descriptors from there. So what this does is this adds some new descriptors that now we can compile. And the descriptors behind the scenes, they bring two things that are very useful for us. They bring some TypeScript definitions so that you have a really good developer experience for interacting with this new runtime. But they also add a little bit of, a tiny bit of weight into your bundle size, very small, so that we during runtime can know whether the current code that you're running in your DAPP is compatible, and to which degree is compatible with the runtime that it's running, so that you don't shoot yourself in the foot. But you can also introspect in your DAPP and see each chain interaction, if it's compatible and to which degree is compatible. And so this means that now I can come to the DAPP, now that I have installed this. And what I'm going to do here is, this is a DAPP that does something, a very simple pattern that it's like, OK, if I don't have to prepare myself for a runtime upgrade, then the current API and the next API are the same. But if I need to anticipate a runtime upgrade, I'm going to do that, right? Like, so let's do client.getTypeAPI. And here I do getTypeAPI for, how did I call it? TX with comment, perhaps? Yes. OK, so now the next API is this one. Then I come here to the provider, and I've created like a super simple provider. I did it myself, but like you can create these kind of helpers using POLKADOT-API or not. But here I'm going to do, OK, next API, .transaction, .balances, .transfer, keep alive, .is compatible. And this provider is going to let all the components that are inside, whether we are in the version before the runtime upgrade or in the version after the runtime upgrade. And now we go to the transfer component. And here we have a simple hook that it does like some super basic validation. And if the validation passes, then it returns a call. And this call is used by this component here, fees and submit. And and the fees and submit is responsible for broadcasting the transaction, showing like that light box that we saw before and whatnot. So let's update this one. It's going to receive a new field that is concept, string. I'm going to add it here before I forget. This is concept. And now here, we want to make sure that we use the API that we must use. Use is next. This is a very simple hook that I created that uses POLKADOT-API internally. So now here, next API. And now TypeScript is already complaining, saying, hey, like, you know, if you can use the next API, like, you're missing something here. So that's because we have really good typings. It's like the comment, you're missing the comment. I call it concept, whatever. So if I do concept, well, TypeScript is going to complain again, say like, well, this should be binary data. No problem. We give you the tools so that you can easily convert it to binary. So let's do that from text. No problem. OK, so the hook is now ready. Now let's wire in the presentational component, concept, set concept. This is a string. We're almost done. Sorry, I know it's painful to watch people coding, but we're almost done. Jeez, well, if I can code. OK, now the field. We're going to add a new field, but we want this field to only appear in the next version, like when the next runtime gets enacted. So that's why I create like a super simple component here that kind of handles that using Polkadot-API. And then this field obviously is going to be called is going to be for the concept. So amount concept G. All right. All right, almost done. Placeholder, whatever, concept. This is not a document input, this is a string input, sorry. And now, OK, now we're done. Now we're done. So now I'm going to, you can see here, I'm using Vite in development mode, so I just saved. And now this DAPP should be able to, let me refresh here the network so you can see. But now this DAPP should be able to work with both versions, right? Like the current runtime and the next runtime. So let's see if it works. Maybe it will, maybe it won't, I'm not sure. So here we can see the runtime upgrade hasn't happened yet. So let's create this transaction. Whenever it gets into a block, it should appear here. Come on, there we go. So we can see that this is still the old transaction. We're in the old runtime. It's still working. Everything is working like it was working before. Now let's trigger a runtime upgrade and let's see what happens. Will this work or what? All right, so I'm going to force a runtime upgrade. And I'm going to hope for the best. Will my DAPP crash? What will it happen? So here we see in block 252. So when block 252 gets finalized, we should see something happening here, 251. What's going to happen in block 252? Let's go. Come on. There we go. Oh, a new field just appeared. All right, so Papi rocks. And if I didn't forget to wire anything, when I make this new transfer, we will see here, it's still working. It's been validated. It appeared. And now balances transfer with comment. With comment Papi rocks. So, I mean, this is a very simple example. But like, we have put a lot of effort into, like, when people ask, like, why do you have a CLI? Well, we have a CLI so that you can create the descriptors from any WASM that you want, from any version that you want. Like, you don't have to go to a centralized, like, npm to install, like, the types or, like, no. Also, because we are not only providing the types, we're providing the safety net for your DAPP to keep on working. And if we see that your DAPP is about to do something that is no longer compatible with the runtime, that it's actually happening, then we're going to raise a well-known error. How am I doing time? Sorry. That will allow you to also react to that. So this is a very simple example. It's not only useful for runtime upgrades, it's also useful for creating DAPPs that, I don't know, imagine you have a staking DAPP, and this staking DAPP needs to deal with many different runtime versions with slightly different, small differences. Like, you can have different providers that encapsulate these complexities and always know whether you're working with one version or the other. I could be going on forever, but in the interest of time and questions and stuff, I'm going to let Carlo continue. Thank you.
Can I ask another warm thank you to Josep? Can we switch again? Yeah, thank you. Amazing. Everything worked super nice. I'm super happy. Thank you, Josep. for the demo. And just to wrap up, I wanted to leave some time for questions, so I will be really fast in the next slide, which is basically what next? What is coming to PAPI? First of all, an important announcement. We will be releasing the first stable version in the coming weeks. So we are super happy. Thank you, Basti. So, oh, it was you. Sorry. So yeah, soonish, but it's in the coming weeks. We are super happy to set this important milestone in our development. And besides the development of PAPI, we want to share as well some news that we want to present in the future, which are, first of all, headless components. So until now, PAPI is agnostic to the change functionalities. So it just understands of extrinsics, executing them, events, decoding them, etc. But it doesn't know the business logic behind each palette, right? And we need to add libraries that add logic for some standard palettes and abstract away from the consumer the how of keychain interactions and keep the what. So, for example, imagine submitting a referenda, right? It's a thing that most of us did at some point. Do we want to bother if it's using a pre-image or it's inlining the payload? Do we want to bother in which track is going? These are things that should be inherited directly, and some users, some advanced users might want to know all those things, but several users might want a simpler API for that. And we want to create a framework that allows as well paraching teams to extend our work on their own palettes. Besides that, we want to help the ecosystem transitioning to a better and modern wallet design. So our wallets were designed and inherit from Polkadot.js extension, which was designed several years ago and has some flaws that we will not cover on this talk, but that we think that we can help to improve and help the ecosystem transition to a well-spec'd, good and modern design. Similar to what happened with the JSON RPC API spec, we want to have the same but for wallets. And besides that, we want to add native ink support, so the same nice typings and safety that we have with extrinsics, events, runtime APIs, etc. We want to have them as well for ink contracts using the contract metadata. And that was my presentation. Thank you so much for being here. And now we still have 2 minutes, so I'm super happy that we still have time. If anyone has a question, I will be more than happy to answer that.
Yes.
Antonio, please.
Yeah, that's great news. I'm really looking forward for the V1. My question is are any of the libraries based on previous work done in the PJS API package, like the old package, or you rewrote everything from scratch?
We don't import in any of our libraries any @Polkadot package. Everything is written from scratch. It was actually one of our decisions and designs that...
Nothing comes from Polkadot.js, but we don't reinvent the wheel. So like novel hashes, for instance, has a lot of the hashing functions that are properly audited. So obviously, why will we implement like a new hashing function that it's already audited, right? Like so for like the super low-level building blocks, we are using novel hashes. But like nothing comes from Polkadot.
Nothing comes from Polkadot. Exactly.
Everything has been rebuilt from with a really good base. Yeah.
Yep, that in the back. So thank you, Antonio.
I was thinking about the experience of building non-web applications with PAPI, because there are many instances where you have to develop something that is not related to a web application or components or
So in that regard, like this is a TypeScript library, so like it works in any runtime that supports JavaScript. So we could port some of our work to other languages perhaps in the future. It's not in the roadmap. That being said, giving first-time support to React Native is definitely in the roadmap. So, and we haven't mentioned it, but like, yes. So we aim to support all modern JavaScript tooling per se. Now, React Native is a tricky beast, but that's it because they still use CommonJS. But we will definitely target support for React Native. I mean, and it is currently working actually, but not as good as we would like it to be.
I was thinking about something more like Node.
Yeah, I was going to tackle that. It is, of course, being supported. For example, just to say a project that is currently live and using PAPI in Node is the faucet for West End, Paseo, Rococo, all that stuff is backed by PAPI.
And Ban.js, like, if you want to try some PAPI with something that works really, really good, go directly to Ban. It works much better.
Next question, yes?
You guys kind of brought it up. Is it going to be ES modules based?
Yes.
Yeah.
And purely ES modules?
Yes.
That was also kind of a pain with PJS.
Yeah.
So by default, like, first class support is for ESM because ESM is the standard of JavaScript, right? Like, so first class support to standards and second class support for CommonJS, if that makes sense. But still, we support CommonJS. Long story short, like when it comes to bundlers, modern bundlers work really well with PAPI. Webpack, sure, like we are fighting it, but it's not our main priority. We'll make it work, but yeah.
Okay, cool, thanks.